In this lesson we're going to look at the technique of galvanizing with zinc. And so we have a piece of iron here, and as you know, the problem with iron is that it will react with oxygen and water in the atmosphere to form rust. And the chemical name of rust is hydrated iron 3 oxide. And the problem with this is that rather than acting as a protective layer against more oxygen, because it's hydrated, it tends to flake off of the iron object and expose the surface again to more oxygen and the formation of more rust. So if you want to avoid this happening, you need to coat or protect the iron. One of the ways to do this is by galvanizing the iron. This means coating the iron with a layer of zinc. So most screws and bolts and nuts and nails, for example, that you buy from an ironmonger will be galvanized. They'll be coated with a layer of zinc. Okay, like that. We've coated our iron object with a layer of zinc, and basically that layer simply acts as a barrier to prevent oxygen and water reaching the iron, just as if you coated it with plastic, for example. But there is one interesting property of zinc which provides further protection for the iron object, which we will now look at. The zinc, because it is higher up in the reactivity series than iron, acts as what we call a sacrificial metal or a sacrificial anode. What that means is that if this layer of zinc gets scratched, here for example, then the iron becomes exposed to oxygen and water in the atmosphere and could rust. However, because zinc acts as a sacrificial metal, it protects the iron. Let's have a closer look at this. So we get our scratch here. That exposes the surface of the iron to oxygen and water. But because zinc is more reactive than iron, what it does is it prevents the iron from reacting with oxygen in the atmosphere. Okay, so the iron, in order to react with oxygen, what it wants to do is lose electrons to the oxygen to form iron oxide. However, the zinc pushes electrons onto the iron, and this stops the iron reacting with the oxygen. As a result, the zinc reacts with the oxygen itself and forms zinc oxide. Okay, so we say that the zinc acts as a sacrificial metal. In other words, the zinc is reacting with the oxygen instead of the iron because it is more reactive than the iron. Now, some iron objects are coated with tin, for example, as in tin cans, or they used to be at least. Okay, and so tin, well, it will protect the iron from oxygen and water in the atmosphere in that it acts as a barrier in just the same way as zinc. However, because tin is less reactive than iron in the reactivity series, it doesn't act as a sacrificial metal. So an iron object that's been coated with tin will be okay as long as the tin doesn't get scratched. But as soon as it gets scratched, then the iron will be exposed to oxygen and will start to react with oxygen. So zinc has this advantage as a method of coating and protecting iron objects in that it is a more reactive metal and therefore acts as a sacrificial metal, and the iron object remains protected when this coating of zinc gets scratched.